Okay, so this is worksheet actually 8B. I changed them around last year. Experimental probability is what did happen. So it's actually when somebody actually flipped a coin and recorded the results. This, bless you, three heads, that's 3 heads, and this is 7 tails, and so the total flips were 10. Okay, so the person did 10 flips. So how many heads? 3 out of 10. So the probability of heads based on the experiment is actually 3 out of 10. Now, 3 out of 10 could be written as a percentage. That would be 30%. Now, the theoretical probability, though, what in theory should have happened? Yeah, 1/2 or 50% of the time you would expect to get heads. So when you actually do an experiment, it's like flipping coins. The more times you do it, the closer you're going to get to that 50%. So what I'm saying is when you don't do it very many times, you're likely to be quite a bit different than what the theoretical probability is. Oh, there's a little thing down there. This is just to remember the definition we had of probability yesterday. Number of favorable outcomes over total possible number of outcomes. Okay. Suppose the spinner was spun 60 times and it stopped at the number 4 on the dial 14 times. What is the experimental probability that the pointer will stop at 4? Well, that would have been 14 out of 60, which can reduce to 7 out of 30. Now, if you wanted that as a decimal, you would take 7 divided by 30, and that's 23 1/3%. Sometimes I like to think about things in percentages. Right? What is the theoretical probability of getting a 4, though, on the dial? So there's 1 4 out of how many numbers? 5. So it's 1 out of 5, or 20%. So that last spinner doesn't look too bad, basically. It's pretty darn close to realistic expectations for getting that number. For any spin, what is the theoretical probability that the spinner will stop at an odd number? Well, if you consider 1 odd, it's really not either. Well, the definition of an odd number is a number that's only divisible by 1 and itself. So technically, 1 is not odd, but it is divisible by 1 and itself, so we'll count it this time. But let's just say it is 3 out of 5. So that would be, if you wrote as a decimal, 60%. Suppose the number 3 came up, or as a percentage, it would be 60%. Suppose the number 3 came up 42 times out of 60 spins. Would you conclude that something was wrong with the spinning mechanism? Yes. 42 out of 60 is really high. Okay, that's 70%. And which is way off of the theoretical probability, which is from the expected. What would the expectation be? That would have been 3 out of 5. This expected 20%. You see what I'm saying? It's 20% is what you expect for any of the numbers to be when you spin it. So having it land on that number 70% of the time is really way off. Okay. All right. Or you could. I didn't write expected correctly. Expected with a C would be nice. All right, 5. A student tossed a coin 20 times and recorded the results. This would be called experimental probability. Experimental probability of getting heads, that's 5, 6, 7. What was the total here of spins or flips? 5, 10, 15, 20. 7 out of 20. Okay. That's about 35%. Theoretical probability of getting heads with a fair coin would be 1/2 or 50%. Okay, now we got an experiment that's already been done. Somebody spun the spinner and recorded their results. So I'm going to jot down these tallies as numbers because otherwise it's going to probably drive me crazy. Okay, so this is 4. This would be, is that 5? I hate it when they don't put a slash through things. That's 5. This would be 7. This one's 3. This one's 8. This is 7. This is 9. And the last one is 7. Okay, so it says probability of getting a 7 in the experiment. They got a 7 9 times out of 50 spins. So 9 out of 50. But theoretically, how often do you think you'd get a 7? Theoretically, there's only one 7 out of how many 8 spaces? So 1/8. Okay. That'd be 12.5%, right? Okay. And this, what's 9 out of 50? 18. I'm not going to do that. I'm just going to write the probabilities down. Okay. Well, I'll just leave the decimals out of it. Now, a 1 or a 5, do you remember what you do for or? Add the probabilities, okay? So we would do 1 or a 5 would be 1 out of, oh, I'm supposed to do, you want me to do experimental first, or I don't care, theoretical first. 1 out of 5 plus 1 out of 5, and that would have been 2/5 for theoretical. Oh, I don't know why it did 5. It's 1 out of 8. Hello. 2 out of 8. I don't know where my 5 came from. 2 out of 8, 2 out of 8, which would be 1 out of 4. All right, and then as far as 1 or the 5 up here, you got 4 and 8, so let's just put them together. That'd be 12 out of 50. And that reduces to 6 out of 25. You got the idea of this section? All right, I'll go ahead and go a little faster then. A multiple of 4 would be 10. Oh, multiples of 4 would include 4 and 8, so that's 10 out of 50 for the experiment, or 1/5. And then a multiple of 4 on the spinner, there are 2 numbers out of 8 numbers, so that'd be a quarter. Okay, multiple of 5 or a multiple of 3. Multiple of 5 would be only 5 up here, so that's 8. Oops. 8 out of 50 plus, how many up there? 7 out of 50, so that's going to be 15 out of 50. Let me just write the answer. And reduced, you can divide by 3. That would be 5 out of, no, you can't divide by 3. You can divide by 5. 3/10. Oopsie. I got to add 6 in there, don't I? Sorry, multiple of 3. I got to use my words. 7 plus 7 plus, what's the other one? 5 would be 8. 7, 7, and 8. What's that total, please? 22? Sorry, let me correct this one. 22 out of 50. And then we could reduce that to 11. 11 out of 25. Okay, and theoretically, again, we're going to have 3 different numbers. That's going to be just 3 out of the 8 numbers, so 3/8. All right, this one says prime. What numbers are prime? You know when I said, I think I said something odd or even. Prime, the definition of prime number is a number that's divisible by 1 and itself, or only. So what's prime? Well, a lot of people don't consider 1 prime, or 2 is prime, 5 is prime, and 7 is prime. So 2, 5, and 7. Can you guys total up how many tallies that was? What did I do? I don't know why I skipped 3. God, my brain's out of on break or something. 5, 3, 5, 2, 3, 5, and 7. Add them up. 12, 29. Did you get 29? That's what I got when I did it. 29 out of 50. All right, as far as prime on the spinner, 2, 3, 5, and 7 would be 1, 2, 3, 4 out of the 8, which is half. or 1/2. Odd number greater than 3. Bigger than 3 and odd. That would be the 5 and the 7. So that would be 8 plus 9, which is 17 out of 50. And then 2 out of 8, which is 1/4. And then finally, probability of a number, even number less than 6. Okay, under 6 and even in the experiment, that's 4 and 2, which is 8 out of 50. And that reduces to 4 out of 25. On less than 6 and even on the spinner, there's 2 numbers out of the 8, so 1/4. Ooh, it matches. Well, the other ones. There's quite a few. The same answer, of course, in the experimental column. Now, let's go to, okay, probability again was number of favorable outcomes over the total possible number of outcomes. Odds are a little different. Odds are the number of favorable outcomes over the unfavorable. Okay, so you don't have a total on the bottom this time. You have to figure out the difference between the total and the favorable and the unfavorable. So we're going to together, and then I'm going to leave some of the evens for you. The probability of each outcome if a die is rolled. Okay, this is probability, and then we're getting down to odds when we hit number 5. A probability of rolling a 2 on a die is 1 out of 6. There are 6 numbers on a die. Number 3. A number greater than 2. Oh, it says 2 or greater. So that means we have to include the 2. So it's all the numbers except 1. So that'd be 5 out of 6. Now odds. Okay, now we're finding what the odds are of a multiple of 2. All right, how many numbers on a die are multiples of 2? There are 2, 4, and 6. So that would be 3. And how many are not multiples of 2? 3. All right, so then that would reduce to 1 to 1. You do write it as a fraction. You do not write the whole number 1. It's the odds. You have to say 1 to 1. Okay? You can write it often. It's looking like that. Yep. A lot of places. It's like if you're looking at the horse races recently. Anybody look at the Kentucky Derby, I think it was, last weekend? Well, anyway, it's got, they do horses. The odds of winning, that's what they're doing when they do horse races. And yeah, you can write it with a colon. Okay, 7, probability of an even number. Well, isn't that the same as what we just did? Multiple of 2 is also evens. All right, so that's 3 to 3 or 1 to 1. You want to write it as a colon? That's cool. Okay, now here's a deck of cards. I told you I think there was a deck of cards yesterday in the video, and you kind of had a peek at them. This is just, again, the clubs. The second one, this one is called spades, hearts, and diamonds. If a card is selected at random from a deck of 52 cards, what's the probability of selecting a spade? Probability would be all the spades out of all the cards. So that would be 13 spades out of 52 cards, which is 1/4 of the deck, 1/4. Right, what's the probability, or the odds now, of selecting a heart? Odds, well, how many are hearts? 13. How many are not hearts? 39. Okay, so the odds are 13 to 39, which reduces to 1, 2, 3. Or you can write it with a colon if you like. Maybe that'll distinct it as different from probability for you. 13, going through the odds. What's the probability of selecting a heart or a queen? Now, I'm going to I'll talk to you about the formula from yesterday, and then I'll tell you that you don't have to use a lot of the formulas in probability. You can use your head. Now, it depends on how you think, which one you prefer. But if you wanted to do, remember, or was adding the 2 probabilities. A heart, there are 13 hearts out of 52 cards. Plus, there are 4 queens out of 52 cards. And then we said yesterday you have to subtract the overlap, which would have been 2 of these are queens. So we'd have to subtract 2. All right, now my pen's got stuck, excuse me. And then you would get the right amount, which would be 15 out of 52. How could I do that without using the formula? Couldn't you have thought in your head that, or did I add wrong? There are, wait a minute. I'm sorry. I only grabbed one of the queens, didn't I? Excuse me. One heart is a queen. It should have been one. This would be 16. Okay, now let's do it without like thinking about the formula. If you said heart or a queen, there are 13 hearts, and then how many more queens would be left? That there's going to be a queen that's a diamond, a queen that's a club, and a queen that's a spade. So you could have done this right off the bat and said 16 out of 52. You see what I'm saying? Why you don't have to know the formula, but you do have to consider the overlap. All right, what's that reduce to? Divide by 4, I think it's 4/13, right? Okay. So I just wanted to explain that formula about the overlap. You can add, but then you have to take away any overlap. There was one overlap of one queen. Okay, 15. I don't know why this is repeated. 15. We already did number 13. 15, what are the odds of, it should say of, selecting a black card or an 8? Okay, black cards, half of the deck are black, so that'd be half of the cards, or 26 out of 52. I'm keeping it with 50 seconds just so that I can get the common denominator. Plus, now if you got all the black cards, how many more 8s are there if all the black cards are gone? You got 2 red 8s, so you can do the overlap that way by thinking in your head. You like that better than the formula, or it's just whatever you got to do to think it out? I could have done 26 50 seconds plus 4 50 seconds minus 2 50 seconds, and that would have given me the same result as what I'm about to get. 28 over 52, then reduce, please. That'd be 7 out of 13, right? Oh, crap. So, all right, let's fix it now. We understood the way to get the probability. So how can we get odds out of a probability? A favorable amount is the top, right? And then what's the difference? Okay, this was the probability. And now we can change it to odds by doing 7 and then subtracting 7 from 13, which is 6. So it'd be 7 to 6. And you can write it if you want instead with the colon. All right, we got a bag of marbles now, and then I got some colorful little things down here at the bottom. You got 5 green, 8 red, 2 white, and 7 blue. Let's see, 17. This says probability, drawing a white or a blue. So there are 2 white marbles and 7 blues, which is 9. How many marbles in all? Okay, we might want to note the total is 22. So it's 9 out of 22. The probability of drawing a yellow marble. Are there any yellow marbles? 0. Now we're going to do odds. Okay, so 21, drawing a white marble. Okay, this is odds. So there are 2 white ones. How many are not white? 20, and that would reduce to 1. All right, you want to write a colon? You can write it with as a fraction or a colon. 1 to 10. 23, not drawing a blue marble. Okay, so how many marbles are blue? There are 7 that are blue. That would be on the bottom because that would be the not part. And then on the top would be the rest of the marbles, which is 15 marbles are not blue. 15 to 7 is the correct order. It has to be in the right order. Okay, back of the page. $25. Now I have a star by 27. And a 24. All right, it's the probability that an event will occur. Now this says it's probability. It's 2 to 5. What are the odds that the event will not occur? Okay, so it says, this was saying 2 will. If 2 will and there's a total of 5, how many won't? 3 won't. Okay, so now I'm going to say what's the odds that the event won't occur? Would be 3, 2, 2. You see how I decided the order there? That's why I labeled these, so I could write it correctly. All right, let's look at 27. If the odds that an event does not occur, okay, are 5 to 7, that means 5 is not, 7 is. So what's the probability that the event does occur? Oops, I guess this should be does. Does not, does, whatever. So if it says what's the probability that the event does occur, would be 7, 2, and now I got to add them up, 12, because probability is the total. All right, next, 29. If the odds that an event will occur are 1 to 3, what are the odds that the event will not occur? Well, all you have to do is, flip it around, 3 to 1. 31, what are the possible range of values for probability? What do you think? You want to know this. What are the possible ranges or values for probability? Well, probability, can there have no chance? Yes. Can you have 100% chance? Okay, so 0 to 1. But probability, odds are different. Can you get no, the odds are 0? Yeah, I guess it not happen, right? If it would not happen. But what's the max? It happens or it doesn't, right? For odds. So the odds of something happening would have to be a number over a number, right? Can't divide by 0, right? So that number could get very, very high, large. So what do you think it goes up to? There you go. I just wanted you to think about it so you'd remember. All right, 33. A number of males and females are enrolled in each grade at Poplar Hills High School, and that's given below. You're conducting a survey on drug use for the school newspaper by selecting students at random. What is the probability that a student chosen is a female in the 12th grade? Okay, so they have to be female and in the 12th grade. Where's that? Female, 12th grade. Got 175 girls that are female and are in the 12th grade. Now it said that a student, does it has to be, so that we need a total of students. So it's going to be 175 out of, now how many kids are there? Did it tell us somewhere? Or did you all add them all up? I think we're going to add them all up, right? So if we got males, 9, let's see, maybe I'll get a total of 1, 2, let's see, 280, 380, 480, 500. Female, 150, 250, 350, 360, 460, 535. I got 535, so the total number of kids is 1035. All right, so the probability that she's a 12th grader, wait, she's gotta be, is female and in the 12th grade. So it's out of the females, okay? Student is shown is a female in the 12th grade. So it's out of the females only, not including the males. So we got to do out of 535. Now, your calculator, of course, can reduce that for you. If you've done it, you should have gotten 35 to 107. All right, 35. What are the odds that a student chosen is a male in the 9th grade? Okay, so it's got to be a male. There are 150, let's see, 9th grade, male, 130 in the 9th grade. What number is this? It's 35. Yeah, and then how many are in the 9th grade? I don't know if I need to do that, though. Male in the 9th grade. So all the males was 500. Yeah, I did. I don't know why it's odds. A male in the 9th grade. The odds of being a male and being in the 9th grade, so I think it's going to be out of 500, and I have to subtract the 130 from the 500. What's that? I don't think I did this right in my notes. 370? Okay. Yeah, student is a male in the 9th grade. I'm just trying to think if it really should be out of all students. No, you got to be male. Male and in the 9th grade. So this should be right. All right, what do we just reduce to? 13 over 37? That's it. No other common factors. Okay, 30. I don't know why that's another 35 there, but whatever. 37. If a female is chosen, if a female is chosen what is that saying? I don't like how this is worded, but anyway, I'll get rid of that word. If a female is chosen, what's the probability that she is a 11th grader? Okay, we got a female in 11th grade. How many females? At 110. Okay, and then how many females are there? 535. Okay, so we reduce that to 22 in 107, dividing by 5. All right, let's go down to an old problem because finals are coming. Remember these chemistry problems? Mixture problems? Okay, I told you to do a percent column, an amount, and a total. All right, a chemist is making 400 gallons of a solution that's 48% alcohol. I'm going to do 48. He's making that though, all right? Is that what starts at the beginning then? So the way we actually set them up is we would always put our totals at the bottom. So I'm going to put my 48 in a different spot. What are we putting together to get that 48% mixture is what I want first. So we're going to mix two things. She has one solution. Okay, the amount was 400 gallons. She has one solution that's 40% and another that's 60. How much of each should she mix to come up with exactly 400 gallons of the 48% solution? All right, we need to do X on one of them, and then what can we write to represent the amount of the other one? Minus X, okay, 400 minus X. Then on this far column, we multiply 40X. We'll do 60 times 400 minus X, and then 48 times 400 is 192,000. Okay, now we can just say this total column added together. And I don't know, you could have just distributed just now. And then we would solve this problem. Okay, if you distribute, you get minus 60x, you're going to get negative 20x plus 24 with 3 zeros. or 24,000 equals 19,200. Subtract 24,000. You're going to get negative 4,800. Divide by negative 20, and we get 240. Okay, so we need 240 gallons of which one? 40%, okay. And 400 minus 240 would be 160 gallons of 60% alcohol. Okay, we talked about odds. The rest of this is practice. Let's go back if you want and maybe do some more permutations. If you want to go on 11, would that be something that was bothering you from yesterday, or page 10? Okay, P10 in the book. Got it.